do want to play some MP tonight, though.
Yeah. He wants to play some Warzone, and he hasn't played in a while. I'll probably do 1 or 2 with him at least. It's Saturday, so.
Yeah, if we're still up. Well, I don't know if he's still up, but
that's why I asked him, like, when's bedtime?
Yeah. What's up, Scott?
Howdy. How y'all doing?
Chilling. Just
How do I
out in
sound?
the Death Star.
Oh, hell yeah. Up to no good.
Well, that just goes without saying.
So how are y'all feeling today?
Well, we have both pretty much figured out that we're tired. We're very tired.
Yeah, that's fair. I can relate.
It has been a hell of a freaking week.
Oh, yeah?
Yeah, absolutely.
Anything worth talking about?
Not so much. I mean, it's mostly work related, so.
Yeah.
For me, I was, trying to buy a house, was very close and fell through. So,
Yeah. Damn.
Yeah, but you're better off this way. Don't worry about it.
Yeah, I'm pretty sure I am.
Did like somebody else get it? Was like another offer? Or?
No, it has some problems that need to be addressed before it should be sold, but
Yeah.
the current owners don't want to do anything with it, so.
Well, at least you avoided a lemon.
Yeah.
That is why it's better off.
Oh yeah,
Yeah.
absolutely. No, I'm happy with it not having gone through at this point, knowing what I know now, which
Yeah.
is the whole point of doing what I do. So, but
Oh,
yeah,
yeah?
basically it had septic issues. It's got a septic tank, had septic issues, so potentially a very expensive repair. It had other issues on top of it too that I was willing to work with, but once I found out the septic issues, and then not to mention that the current owners weren't willing to do anything or work with me on price or anything like that, it's like, nah. So,
Yeah. Needless to say, that's pretty shitty.
yeah. Well, I mean, their thought, which is absolutely correct from their standpoint, is right now it is a seller's market, and basically they're going to get the next person that offers them money is probably going to buy the house, So,
Yeah.
but for me, somebody who can't turn around and put $30,000 into it in, another 2 to 5 years, it's just not going to work for me. So,
Yeah, it's a money sink at that point. It's a pit.
That's it.
Yeah.
Don't worry about it, because next time you drive by that spot or whatever, and the sale sign's off, you can just laugh.
I won't be driving by there too often unless I end up moving up that way. But yeah.
Yeah. Well, you didn't particularly care about for the area either, did you?
No, I don't. It's a lot further north than I really want to go. I mean, it's outside of the area that I'm in now, and so it was something that I was just trying to see if it was going to work, and it didn't.
Nope.
So the search continues.
It's fine. You'll find something. Like I said,
Yeah.
you got a place right now, so.
Yeah, exactly, and I actually told that to my realtor too. I'm like, look, when she told me that they were like, when they told me they weren't willing to negotiate on price, basically, they were like, we are moving and we need this house to sell so we can get the other house. And I'm like, yeah. So I ended up telling my realtor, I'm like, look, I understand that they're doing what they're doing, but I got to do what's best for me. So I don't really care if they're moving soon or not.
Yeah.
This was before I got the information about the septic system. And I'm like, as soon as I found out I had a septic, I'm like, I need the inspection. I need the report that it's been taken care of and stuff like that. The owners wouldn't provide anything, indicating they probably have never had it done, or if they have, not recently. And given the age of it and everything, it just wasn't something I was going to leave the chance,
When was it made?
62.
Oh my God, yeah.
Yeah, and septic tanks only last 40 years, and it's probably never been replaced. So,
Yikes.
Yeah.
So it is what it is.
Yep. You don't need a money pit, so it's fine.
Nope.
Yeah.
keep working at it, saving up, help me in the long run.
Did you guys see the two images that NASA released since the Hubble's been back up and running now?
The galaxies.
Yeah, I'm like,
Yeah.
out of all the pictures of all the cool shit that has come from that telescope, just like proof that it's working, I guess they just like released 2 pictures.
I think so. I think they were just they were meaning to image those before, and then they were like, yeah, these are just test pictures. See it and make sure it's working.
Yeah.
Hmm.
I'm
Yeah.
not sure exactly, but
I'm posting the 2 of them right now.
Yeah, I haven't seen the pictures, but yeah, I'm sure that's what it is. It's just like, here's proof we got it up and running again.
Yeah.
It's
I
like,
mean, that sucker's been in service quite a while now.
something real quick here. I'm like, oh yeah, absolutely. What? That thing went up in what, the 90s, or on 1990 or something?
Something like that. Yeah.
Something like that.
Yeah. But I'm
I
like,
mean, those look pretty cool to me. One's like a merger. It looks like a galaxy merger potentially.
compared to some of the other stuff that the telescope has come back with that they've released, like prior to its last system failure or whatever, or the computer going down, it's just like, yeah, they're kind of lackluster. I'm just,
Well, I remember the one thing about the barred spiral there, not the 2 galaxies merging, but the other one, that was unique about it is that it has 3 arms when normally they have like an even number of arms.
Yeah, it looks almost like there's a little one that's kind of disintegrated. You can almost see like not like a
I was
vestigial
thinking
kind of
that it
one.
might be like a collision too, and it's the trail of it being absorbed by that galaxy.
Yeah, it could be something caused by a merger, some instability. I recently saw a video kind of talking about how galaxies don't really move the way that you tend to think that they move. Like the arms, like everything is really kind of moving at like different speeds, and there's like gas and solid matter. And you know how there's like the arms, well, a lot of them do kind of rotate the way you would expect, but some actually rotate, they look the same way, but they're rotating the opposite way, like the arms towards the arms, like not the way you'd expect, like you'd see a hurricane rotating, they rotate the opposite way.
That's interesting.
Yeah, and I guess it probably has to do with like the orbital mechanics of how all this stuff is moving around. It's fascinating that those arms they're not all like the arm moves around all together. It's like a bunch of stars and gas kind of all coming into that area, happen to be about at the same place in time, but that could be a different set of mass, a different set of planets once it's like all the way halfway back around. It's just that for some reason the forces tend to cause like an accumulation in those arms.
yeah, I've never heard that. So
Yeah, I didn't know that they could like spin the other way,
Yeah. And the arms still be shaped the same like they are?
Yeah, they like swoop that way, but they're moving towards the swoop instead of like swooping away from it like you would intuitively imagine. Most do that intuitive way, but there are some that go the other way for some weird reason.
still manages to stay like that.
Yeah, because the arms, it's not like these stars make up this arm. It's like that changes over time. What makes up the arm? The arm is like this kind of transient structure. It's apparently similar to like how the rings of Saturn are apparently. Like the rings of Saturn, they're obviously not like a plate around the star. It's really just a bunch of little tiny meteors and stuff that
Chunks of ice and rock and dust and
yeah, and those change over time. And apparently there's like one area that looks like a bunch of little lines, like a bunch of little tiny thin narrow rings, but it's actually one like record track, like a spiral. It's actually like an arm, a really long arm that kind of folds around in on itself.
that's interesting.
Yeah, there's almost certainly pictures that you could look up. But yeah, it's pretty neat. Anyway, did y'all hear about the like in Waterloo, like kind of town a few hours away from here? There was 4 cars stolen like recently, like within the last week. And they all had like key fob type mechanisms. They had like keyless entry and start, like push button start.
Right.
and they were all four stolen. They think by like the same people probably.
It would make sense, yeah.
It's just crazy. I couldn't help but think like what the future of that might look like. You know, as we get more and more electric cars or more and more like self-automated cars, they're basically like a computer, but it has its own wheels that you could have it program it to drive itself away.
Hacking and like kidnapping and stuff, the game's gonna change.
Yeah, you don't even need a person to get in the car to steal it. You can just send the right signals. It's just crazy. It's wild.
I mean, keyless entry and push starts have been around for a while now. I don't know.
Right.
I'm assuming that they used. That's how they got into they got the right transponder codes or something or whatever to unlock the car.
Yeah.
Assume that's what happened.
Yeah, they're basically guessing. They don't really know exactly how they did it, but they're kind of guessing that they spoofed a key fob. They basically had something that like read like maybe they hung out around this person's house or something and waited until they got like a key command. Like maybe they locked it from inside their house, but they were able to pick up that signal and then spoof that into their own key fob and then use that to gain access to the car.
They used to be able, I'm sure they still can, but with garage doors, with automatic garage doors, like they could do the same thing, like capture the signal when someone opens it or closes it.
Mm-hmm.
Yeah. Well, that's what is that? That's like radio frequency stuff, I think, right?
A lot less complicated than a car, but it's still pretty much kind of the same deal. They're just waiting for someone to hit the button so they can capture whatever transponder signal is communicating with it, I would assume.
Yeah, because those things are like always passively listening, right? And if you just give it the right little ditty, the right little booty boop from like whatever signal, then it'll tell it to wake up, and then it can take in a command. And if you know the right command to give it, you can tell it to open the garage door. Yeah.
But I too, like Teslas, like they have phone apps to control, to lock and unlock the car and everything. And they have like whole apps that control the bloody things. So I don't know what type of securities they got on that stuff, but never really looked into it. But I mean, technically you're right. I mean, if somebody could quote unquote hack into a Tesla and make it drive away or drive to a location or something, that would be interesting.
You gotta steal the car to steal the car. I mean,
yeah. It would make that movie Gone in 60 Seconds a lot more boring of a movie.
Well, they did do. Yeah. So what did they do in that movie? They used like the garage door scanner thing. I remember from that movie. That was a thing. And then what was like? I don't know, when they were stealing like the more high end ones, like they from that dealership, I guess like the Ferraris or whatever. They had like that electronic key that they would insert into it, and then like it just kind of started like an algorithm program or something. It was like guessing the code for it.
It would be like
the code, they turned the key and it ran. And I was just like, okay. I was like, I don't know if any of that's actually true or not, but I mean, that's still kind of neat. I don't know if that's actually how it works.
Well, like I know even just like my Honda Pilot that was like an 05 that I used to have had a chip, which is basically just like an RF tag kind of chip in the key that like, even if you had the exact right cut of key, it wouldn't actually turn the vehicle on. You needed to have the RF chip or whatever exactly the technology was in there to tell it to turn on.
Yeah, that's why when you buy a new car, like they'll give you when you have the keys, there's like a little silver like stamp plate on the keys that has a number on it. That's what you'd use to if you lost your key, so you could reorder a new one that would still work with your car. So
yeah, but if they only use like 4 bits or something like that to do that, it's like a 4-digit number or 4 binary digit number, then that's only like 10,000 combinations that you could probably run through those really quick with the right.
Yeah, that would be a joke for a computer to figure out.
Nowadays,
But
the thing any car that can receive a wireless signal of any kind can potentially be hacked. That's the thing. I mean, it doesn't even take a physical device. If it can receive a wireless signal, which is at any key fob, basically, and a lot of cars people don't realize actually have cellular technology in them to communicate wirelessly. And it's pretty interesting because you could just sit back with a laptop and a Wi-Fi scanner and kind of watch people's cars go by.
Yeah, and as that becomes more
not
common,
quite that simple, but
yeah, and that's only becoming more and more common. So it just, these risks become more and more prevalent, I think.
Oh, it's just like what do you call it? Like all the cyber stuff or whatever, like the ransomware attacks. It's like I seriously think that the security could probably be beefed up better than what it is, but is it, people look at it like, is it worth it? How hard is, like, how common is this going to be a thing? So I don't know, but that would definitely be interesting if you can like James Bond some shit and like, you know, steal somebody's car and drive it with your cell phone and just control it with your finger.
yeah.
That'll be on the next Fast and Furious.
Yeah, right.
It's the next model of Tesla, the one that's only going to cost $15,000.
Yes, truly accessible for everybody.
Yeah.
Shit, I'd buy that.
Yeah, I want to buy
that for $1.
Damn.
Yeah. All right. So, welcome to Technically Incorrect. I got it right this time. Thank you. I actually had to pause, so I thought about it. But I'm Rob. I am joined by Joe and Scott, wherever the heck they are on your screen. And today we had, the carbon dioxide removal thing. We talk about a lot about batteries here, but this is apparently what I thought was actually using a kind of battery to remove carbon dioxide from the air. Turns out it doesn't seem, after looking at this whole thing, doesn't really seem like it's a battery at all. They're just using electrical charge to get the carbon dioxide out of air and then release the charge and let the air go through or something. But they're able to separate the carbon dioxide. But
yeah, that's exactly what the point I made. Like the main point I wanted to bring up was like the headline is like a new kind of battery that removes carbon dioxide from the air. But then you like read it and it doesn't
put a bunch of power into it.
Yeah, it doesn't say anywhere that it's like storing any power. It only mentions how it does the carbon dioxide storage. Like it absorbs all that neato, stuff. It grabs onto it and it can release it later, which is cool. And apparently, because they're basically just trying to sell it like why we need CO2, but they never really sell us on the energy point at all.
Well, I think the idea is that it's not really meant to be a battery, quote unquote. It is more meant to be a CO2 capture device. But as Rob said, we've talked a lot about batteries, about storage and stuff. It was a catchy headline, I think.
Yeah.
Now it is actually still a battery, because as it captures the carbon, it's storing the energy that it's using to capture the carbon. Then when you let it go, when the carbon's released, it creates energy again, and that's how it puts the energy back into the system. So it isn't generating energy, no, but it is a battery in the sense that it is storing a charge and then releasing a charge. So I think that's what they're getting at with the whole battery thing. Not that it's supposed to be the next storage medium, that's not the idea.
But they don't even talk about, at least in this article, they don't even talk about the energy storage properties. They do talk about charging it and discharging it, but they are only talking about the CO2. And I don't get anywhere that you're actually even able to like use that charge when you discharge it. Maybe you can.
When you
discharge the charge cycle.
Yeah, it's being used to power the device purely.
To help recharge it, basically.
So you're using less power off the grid, I guess, or whatever, to run these devices. Because apparently, I mean, I never really looked into it until I read this article, but apparently current, CO2 like removal systems for like fossil fuel plants, they have, they're extremely expensive and they use like thermal a lot of thermal energy and temperature wise and pressure stuff to work or function properly. And this didn't need any of that. It was extremely cost effective way of removing CO2 from air, which I thought was kind of neat in itself and still worth talking about.
Yeah, I think I vaguely remember like one of the main ways we get CO2 is from some process of like actually burning like coal and wood, but with, like you were saying, I think like with high pressures, and you get the ammonium and some other carbon products from that, and they do like a reaction to turn it into CO2.
Yeah, there's a chemical thing that happens because they use it in with like farms with greenhouses or whatever to provide CO2 to feed the plants. They'll like burn natural gas or whatever to create CO2 so the plants have more food or something like that.
Yeah.
But yeah, this was basically like I'm assuming this was designed to be something that you would put in the airstream of like a fossil fuel power plant or something to reduce its emissions drastically. And what they're saying, I mean, I read somewhere, I think in the actual article, the first article that I posted on it said that it was like 80% or whatever effective at removing the CO2 levels. And then
down to
0.8%. Where I pulled that short video that I put in Discord on how this thing operates. They were saying it was like they can literally remove like 100% of the CO2 and then hold it against the walls or whatever while it's being charged, let the air pass through, and then they release the charge and then send the carbon dioxide somewhere else to be stored, either to, they were talking about using it
other
for
industrial
beverage stuff, like for soda plants, like to do the
because it's not storing just carbon, it's storing carbon dioxide gas.
Mm-hmm.
I mean, that is another distinction we want to make sure is clear.
Like, yeah, we use carbon dioxide for stuff. I mean, to soda bottling plants, like I mentioned, I guess I saw an article on the farms use it or whatever. So, and they also mentioned that pumping it back into the ground is another thing they do with the excess or can do with the excess. I don't know if that's like a safe thing. I have no idea, but if that's
CO2
thing for pumping that shit back into the ground, I have no idea what happens to after the fact. But
what would the point of that be?
I think it's just to get
sequestration.
Yes.
Yeah, it's just to
Hey,
sequester,
it's
so it's not in the atmosphere.
Oh, but
Because
that would
CO2 is a natural greenhouse gas, so it holds heat. So we put it in the ground, and that way it's not in the air.
Yeah, I see what you're saying. That seems like that would take a lot of energy too, to like do it, get it deep enough so that it doesn't just leak out into the atmosphere.
I don't know how any of that process works, but
you know what this reminds me of, or this makes me think of, is the International Space Station, how they deal with their CO2. You know, do y'all know anything about that? Like the
not
CO2
exactly, but I know that they were talking that this could be an application for that because of the whole, if you will, lower power usage, because it generates the charge when it's releasing the carbon.
I just figured they were still using like CO2 scrubbers or something.
Yeah, well, do you know how those work? That is what they are called. It's literally,
I just know the term.
it's something called zeolite, Zeolite, and it's like a type of porous, spongy rock, basically, that they'll pump the air through, and the CO2 will bind to that, much like what's happening in this battery. Actually, they just do that with an electrical charge to generate the attraction to the CO2. This is like naturally, the CO2 kind of gets caught in like the little tiny bubbles, if you want to think of it that way, in the zeolite, but on like a molecular scale. And then what they do is they basically submit that to the vacuum pressure of space, and that pulls it all off. It pulls it off the stone. All the CO2 goes out into empty space.
That's pretty cool.
Yeah, it's really like simple, right? It's literally just using a stone that kind of does it and pumping it through that kind of
you need to wash it, you just stick it out the door and pull it back.
Yeah, the space is designed.
This would only work in space.
Yeah, but well, yeah.
Well, that's pretty cool though. I mean, that is a pretty ingenious way to do it. Just have something that is so reusable and so easy to clean and maintain that it's not going to be a problem.
Yeah. But back to this technology, any kind of sequestration thing is good, and we should be looking into it. It also makes me think that, like, I remember hearing some figure that like something like 5 times the amount of CO2 is actually in the oceans, or is like able to be dissolved in water. And basically that makes that a big tank of CO2, if you want to think of it that way. So if we could figure out a way to sequester CO2 from the ocean, that'll kind of create this sort of CO2 vacuum that we'll want to pull that CO2 from the air. Yeah, because that happens anyway, and increasing CO2 in our atmosphere has kind of it's caused what's called ocean acidification. And they think that acidification is linked to like other things like coral reef health and a lot of other things. But this would kind of be undoing that acidification, basically. And that's like a much bigger reservoir of CO2 for us to be going after. So, certainly another avenue to be looking into as far as sequestration techniques.
That would be interesting. So would you say like run seawater through the channel that the air would normally run through to get the CO2 out of it? Is that what you're saying?
I'm not even saying anything specific, just that like this is focusing on getting it out of the air, which is great, but it might be scratching the surface compared to finding other ways of attacking this sequestration issue of trying to get CO2 out of our environment.
The whole point of this is from the design, this looks like it's like not something that you're just gonna like find randomly as you're driving down the highway trying to clean air with this thing.
No.
I mean, I guess it could at some point, but I don't know. But it seems like it was designed for fossil fuel plants, period.
Well, yeah, it's a technology that was just designed to be used to help.
They're cleaning the air through this process, but then they're able to capture all this pure CO2 in the process. Now what do they do with it?
More soda.
Yeah.
More Coca-Cola.
So I just thought that was like an interesting add-on there. They're like, oh yeah, we can give it to greenhouse farms. We can give it to soda plants. I'm just like,
but wouldn't that just be putting it back into the fucking atmosphere? We're gonna drink it.
Yeah.
We're gonna burp it out. We're gonna fart it out. Even if we like die, then it'll just eventually be our CO2 from that's just gonna go up into the air.
That's what I was like, okay, so you give it back to like Coca-Cola or Pepsi or whatever, and then they use it to carbonate sodas, and then we crack the lid or pop the can, and okay, we're back to square one again. I don't know.
Well, I think the idea is that they can just help to supply it, but the main sequestration will be going to putting it in the ground.
Yeah,
I'm sure.
That's what I would figure. I didn't realize that CO2 was that hard to come by, to where we like needed to
harvest it and give it to some other companies.
Yeah. I'm pretty sure that Coke and Pepsi have been doing just fine before this device was invented. But
yeah, I mean, it really is something we take for granted. I don't think how we get our CO2,
Yeah, no, I certainly don't.
Yeah.
Have never thought about it, actually.
But it makes me think of, do y'all know how we get our helium?
No.
Like, apparently helium is a very finite resource on Earth.
UV, I think, right? We actually take UV and split.
That would be neat. UV is just the light, but even like you're kind of getting at an interesting point that stars, our sun has a fuck ton of helium and hydrogen, and it's spewing that off every day. Like I think last episode we talked a little bit about the solar flare. That was a bunch of helium ions coming our way, but we don't really have a good way of capturing that in a meaningful way and then putting it into like balloons, because that's like really ionized and all that and high energy.
Our MRI machine.
Basically what we do is, that's a good point. You need liquid helium to run MRI machines. It's a little more important than balloons, I guess.
It would.
Yeah. Just slightly, it's okay.
basically it comes from radioactive rock, and as it comes, basically the radioactivity is called alpha radiation, and they're literally just helium nuclei without any electrons around them. So they're just a bound set of 2 protons and 2 neutrons that float up through the rock, and on their way they pick up some electrons and they become ground state helium. And so we're able to then harvest that helium and use that. But there's only so much of that. You know, we only have so much radioactivity going on at any given time. So we can't just like have an infinite amount, you know, ready to go. It's whatever the Earth is able to produce, and produce these little tiny pockets of helium that we can mine from. So we get it out of the ground, basically.
Interesting.
Yeah.
Yeah, you mentioned something. I didn't. I think I was looking at something the other day, and I don't think I ever posted it. But what they're doing with since sun was brought up, the plasma fusion reactors. Have you seen anything about those?
What about
a new company is building a new research and testing facility in Washington. I saw in that an article about that, but
I forget what the machine itself has got a weird name, but I guess there's like one over in Britain, like a small one that they're working with, and then there's one here now.
The tokamak is the one I'm familiar with.
I was going to say Tomahawk, but yeah, it's like tokamak or something like that.
I think that's what they like based the like Stark reactor off of from Iron Man, like the first or second movie or something like that. I think that's what they based it off of.
What, the arc reactor thing?
Yeah, I think they based that off the real life tokamak reactor. Like as like a toroidal, like a torus shaped like path kind of thing, or like reservoir for the plasma.
I was looking at that and I'm like, okay, so I'm assuming that nuclear fusion and plasma fusion is like the same thing, or is that different?
Fusion is fusion. It is 2 atoms fusing together. So,
but the way this article was, it was making it sound like if you could, I guess the reason why we like strayed away from it or didn't really, I mean, I don't know, it was a whole containment thing on how we. Because it has to be so hot. It was like literally hotter than the freaking core of the sun or something. The issue reaction going.
The biggest issue is we haven't figured out a way to actually get energy out of it yet. It seems from like mathematical models and stuff, from physics models, that you can get energy out of it, but we have not figured out a good enough way to actually make it worth it. We end up still needing to put more energy in than we can effectively get out. So it's a wasteful process, but it does produce a bunch of energy. We also just have to use a bunch to get it to work. And we're trying to narrow that gap, and hopefully researchers are hoping we'll reach a teeter point that it'll be like, well, actually now we've surpassed it. Now fusion is cost effective basically for producing energy.
The last thing I heard about it was that it takes a fuck ton of energy to like start or initiate, but then after that it was like supposed to be self-sustaining.
Yeah, that's kind of the question. I don't know all the numbers on that, but yeah, people probably try to argue that, well, if we ran it for 25 years, then it would eventually be better. We would eventually get stuff out of it. But putting a whole bunch of money into something that you have to wait that long before it even starts producing valuable energy.
Is it really that long though?
I don't know. I was just pulling a random number out of my ass. Just saying, because I have no idea what the numbers are. But yeah.
The article I read, and why don't I just put this here? Let me
just put this right.
ITER was what this thing was.
Yeah, is that the largest magnet that's ever been built or whatever?
Because they talk about in this article, like actually capturing the energy and how they're trying to do it, I guess, with the magnetic fields and stuff, which again, I'm not overly familiar with, and honestly was kind of thinking you might know more about it than me.
I mean, not really, not much. Just kind of the issue that like what I was just saying, that like it's something they've been trying for a long time, they've also been trying to like lower the temperatures at which fusion happens, because they think that's another avenue at making it more efficient, is trying to do it closer and closer to room temperature, you know, or even cold fusion is what it's sometimes called. But there's been a lot of issues with that, you know.
Yeah,
There's actually
there was a movie based off of that, the cold fusion thing, the Saint.
oh, interesting. I'm not aware of that.
Yeah, it was a spy like sabotage kind of movie or whatever, but it just centered around trying to steal the formula for cold fusion. So
Oh, okay.
still a decent movie. It was what's his name? The Batman Val Kilmer, I think. Yeah,
Gotcha.
pretty sure it was Val Kilmer. Anyway, but yeah, I just kind of happened across this the other day. I was like, yeah, I don't know if I want to talk about it, but I didn't really know anything about it. But yeah, I just thought that was interesting to come back and see. I don't even know, where the heck was this article from?
So they're talking about using heat from the nucleus hitting the walls of the chamber, because nucleuses don't have an electron, and therefore they aren't confined by the magnetic fields of the other particles are. So when they hit the outside of the chamber, it creates thermal energy, which then is carried away from the chamber by liquid cooling, hopefully to provide steam turbines.
Right. So yeah, they basically
Funny how it all comes back to
steam
turbines.
engine.
I mean, that's
The most
effectively
advanced technology, nuclear power plants, and what does it power? A steam turbine.
well, that's basically how the fission reactors that we have that
Yeah.
that are effective. They just are heating up a water tank in most cases that
Yep.
you know turn a turbine, a sturbine.
Turbine. It's just make up words as we go along.
You know, it stirs things up. It's a sturbine.
So what was
That
this metal water into metal thing you had here, Jeff?
So there are in
That was interesting.
under a bunch of pressure, almost anything will turn to metal or a solid state, basically. And similar examples are thought to be like in the core of like Jupiter and stuff, is that it's got so much pressure that it can eventually turn pretty much anything into a solid. But the idea is that water, we know that water can reach a metallic structure and density, if you will, but it's hard to do that with the pressure needed. Like, we can create the pressure, but we can't really observe or anything like that in the environment that we can create that pressure in, apparently. So another way was devised to do it, but by using another type of metal that reacts with water. I don't remember the exact types, but basically these metals, when they're introduced into water, can actually have quite the violent reaction of explosive proportions even.
It was, can I just say?
Yeah.
It was sodium and potassium, apparently.
Yeah. So when they are,
Bananas?
well, pure potassium, but yeah. When you drop these types of metals into water, they can have a very energetic reaction, if you will. So the idea was to take just the littlest amount of water and add it to the metal instead and see how that happened. So they got a really tiny drop of this liquid metal, basically, and then they use a water vapor to pool a little bit of water on the outside of the drop of liquid metal. And it ended up, at one point, it got to enough to where the pure water was able to conduct a charge because it turned to a metallic substance. And pure water is just hydrogen and oxygen. It doesn't create a charge. It's actually an insulator. It's all the impurities in water that make it have be able to transmit a charge. So the fact that it hit that metallic structure and was able to carry a charge is a significant thing without the pressure necessary normally. So just, kind of interesting, not really anything groundbreaking, but
Yeah, you explained that really well, but like the thing that I could not wrap my head around this whole time, it was like it seemed they were talking about the like metallicity of Jupiter and like the extreme pressures and all that. And it seems like this is something very different. You know what I mean? Like they're not, I know that they were saying you don't need pressure here, but it seems like what you would get.
Oops.
But before you were so rudely interrupted,
I'm like, and we're back. Go ahead, Scott. What were you saying?
I mean, I was kind of blathering anyway, so I'll just kind of say it seemed like it was different than the whole pressure metallic, what I imagine metallic water due to pressure seems like a totally different thing than what they did here, which was basically have metal and like sodium potassium alloy. And they even talk about how it dissolves into the water droplet. And they're talking about like pure water. Well, for one thing, that makes it not pure water anymore. Maybe I'm misinterpreting something here, but it sounds like some of that sodium and potassium dissolved into the water and created the ability to conduct electricity. But I just think of salt water. Like salt water has sodium cations in it.
Oh,
they
yeah.
even talk about the cations going into it. And we know that can conduct electricity. Like I did that in my chemistry 1 or 2 class where we like made a little not fake, but like a half cell battery is what they call it. And it was using just salt water.
sodium water,
Yeah. This just seems like a really fancy, nifty way of kind of doing that kind of thing. But when I think of fucking Jupiter, I don't I don't know if y'all knew that before the article, but yeah, they hypothesized that there is metallic hydrogen. Like technically,
It's talking
so
about
much
Uranus.
pressure. Yeah. What?
yeah.
It said Uranus, Neptune, and Uranus. I think.
Whoa, you don't got to go there, buddy.
They were talking about a
I'm
different.
reading, man.
They were talking about a different thing on Neptune and Uranus. Jupiter was the whole where it should be. I think where we believe there is metallic water, though. The other was some other element, wasn't it?
It was liquid metallic hydrogen.
Hydrogen. Yeah.
So liquid hydrogen being like part of rocket fuel. I don't know.
But this was in like such a high pressure state that it wasn't just liquid hydrogen. It was like pressurized liquid hydrogen that made the electrons flow around each other much like they do in a metal. That's kind of what it means.
Yeah.
You get these delocalized electrons, or electrons that aren't just bound up around a single atom. They can float around amongst the sea of all the other atoms.
Yeah, the idea is if you have 2 planets that are orbiting and you squeeze them really tight and you get their orbits close enough, the electron from this one can go over here and the electron from this one can go over here.
Oh, I thought you just like compress them and then we have flat Earth, right? Is it? No.
Y'all lost me. Y'all over there talking about some pseudoscience?
Yeah, probably.
Mine was just a visual representation of what kind of is happening in the fields of energy.
Yeah, I gotcha. Yeah, I kind of think of it as like a big bowl of like cereal or something. But like the electrons are the milk, whereas the atoms are like the Cheerios kind of thing. You know? The electrons are can kind of be everywhere, and that's what kind of allows the conductivity. I want cereal.
I was like, now you're just making yourself hungry.
Yeah, why does it always gotta come to food?
It does. It always does. Did you ever get any of those cheese dust packets from
No.
You didn't want to try them?
I'm just gonna like wiping them off my nose. No, I
You gotta do it. You gotta do it.
You gotta do a video with some
Yeah.
the macaroni and the cotton candy one. You gotta,
You gotta get one of each bag and try it for us, Scott. Come on.
No, the other ones I could care less about. I just want to know what that cotton candy one's fucking like.
I'm sure that jalapeno one is delicious.
Oh, I'm sure.
But,
See, this is why you need to try them so we can find out.
yeah, maybe I will.
Take one for the team, man.
What do I do with the cotton candy one? I don't even know. I don't even know what to do with it.
Follow the directions.
It's like
maybe.
powder, just like the Kraft mac and cheese gives you a powder, so you cook up the stuff and you put milk and mix it in pasta.
milk and cotton candy.
I don't want to waste perfectly good milk and macaroni noodles. That sounds like a waste.
Mike just said
Maybe
he does that. Yeah.
Maybe I'll do this scientifically, and I'll like make a bunch of noodles, and then I'll just make some mac and cheese with it. Then I'll pull like a little aliquot of noodles and make a little tiny little bit.
Yeah.
Okay.
That way you're not like, but then you're still gonna have like this whole package of cotton candy cheese
Oh
done.
God.
That's okay. It can be sacrificed. I wouldn't worry about it.
Man.
Just go out and pour it in your grass. At least then it'll go back into the earth.
Like how they used to tell us what to do with motor oil, spent motor oil.
Oh yeah, that's a good idea.
Just dig a hole and put it in the hole and don't tell anyone about
Don't
It'll be fine.
Any place that sells oil by law in the United States anyway has to take the shit back, the old stuff. So if anybody out there is burying the fucking oil in the ground, take it back to the damn store you bought the new stuff from. Damn it.
Yeah.
And
You tell
Absolutely.
like end rant.
Get them, Rob.
This is someone that what do you call it? Owns too many damn cars. I care. Whatever. Anyway, the other thing I had up here, I've been kind of, because when we were talking about the AI stuff, whatever, last time, and when you had brought up about the not being able to see what's going on in the black box thing, just give it this, it spits out this, and whatever happens in between, we have no freaking idea. So I was looking up stuff on that or whatever, and then I came across this other thing that the guy was using the some AI algorithm or whatever to what was it? He was predicting like
Planetary orbits.
or something.
Yeah.
And
Without actually being programmed with Newtonian laws of physics.
Yeah,
It was
without
given
actually
an
knowing.
example of a planet's orbit and was said, here, this is your basis. Now tell me what you think the others would do. And it
Yeah.
came up with its own answer, which was right.
Almost certainly a lot more than one orbit, but yeah.
Well, yeah, no, I read the article. It is more than one orbit. I was just giving an example.
Yeah.
I just want to know if it has trouble, like tracking the round planets versus the flat ones.
The flat ones are harder to track because if they're edge on, you can't even see them.
Depending on where they are in the rotation.
God damn it.
All right, just
man.
can't get away from that. I didn't. There was a lot of stuff in this article, and I was like, oh yeah, that's neat. I don't really understand what you're talking about.
Well, like,
to the point of the fact that we can have an AI and give it something that exists that we know, and then just kind of let it go and do its own thing without really teaching it anything about. I don't know if you would call it science or whatever. I mean, they mentioned that they didn't bother teaching it, Newton's law or anything, so it didn't have that to go on. But is it really being intelligent, or is it just doing what it's programmed to do?
And that was kind of, I think, the ultimate question at the end of the article was, what doesn't this more or less just define the difference between being able to understand something, like, okay, that's how planets rotate, that makes sense, or being able to know how or why, the actual comprehension of the information, knowing why it happens, not just that it does, but
I'm more interested
deeper
to know,
understanding.
like, if the black box is actually like smart at all. I mean, if you give it something that is, and you tell it, all right, now tell me how the rest of this is going to play out, is it just making calculations based off of what you told it so quickly that it just seems like it's smart. I mean, I don't know.
And
Well,
Scott's about to say, now we just need to define what smart is, right?
Exactly. Yeah. How do we define intelligence in this case?
We don't.
Oh. Okay.
Well, if
Talk
you're
done.
gonna take a stab at it, I'm all for it.
Because it's not really like it's responding to human input or anything like that. It really is just running a set of calculations based upon an algorithm you programmed it with.
And it's not self-aware. It's not going to become self-aware by any means. This is a very different thing than like what we think of as AI that we see in sci-fi movies. It's not that generalized artificial intelligence. It's a very specific type of artificial intelligence.
I mean, the only benefit that artificial intelligence seems to have in this particular case, I guess, is that it thinks a shit ton faster than we do.
Yeah.
All it does is it analyzes data and extrapolates what it thinks is going to happen to more data. That's really all it's doing.
And that's always a scary prospect to me, especially when it is a black box, because we have no sanity check. Because there's always the fear, the underlying fear that you're biased towards your data set. And our data set is never complete. We're never gonna map every single star and galaxy and piece of atom and matter in the universe. So we're always gonna have an incomplete picture. And so we're always gonna be somewhat skewed, and maybe we could get fooled. You could say this about our studying this as humans too. You could make that argument, but I think it's an even worse problem when it's a computer that's just a dumb box of rocks that we don't even know how it's doing the thing, and we have no sanity check to make sure. Yeah, it could lead us astray, and we not know how or why, or even that it is leading us astray until it's like too late.
So
And
It's like we're just making it good enough to be dangerous for us.
Yeah, like it's kind of like what we were talking about last week. It basically, this just shows that it can do it, that it can be done. Like it doesn't really show us how it did it, and so we didn't really learn much from it. But I think, like I reading this article, I simultaneously like agree with some of the things this guy says, and I disagree. Like, yeah, I don't know. Like, I don't know. What do you guys think?
I already said I didn't really understand most of what he was talking about.
Well, like you mentioned how it does kind of make you rethink the idea of intelligence and all.
Right. But yeah, that was just, like I said, I was looking for why we can't figure out a way to track what's happening in the neural network of an AI, right?
Okay,
And
let me
watch this, and it wasn't really what I was looking for, but I was all like, oh, this is kind of neat too. So I read a little bit of it, but when it got more toward the bottom and talking about others, I was just like, yeah, okay, I'm done.
Well, he makes the point that like the ultimate goal of science is to make good predictions. That is true, but like I think if we're only able to make good predictions and have no idea why, then I don't feel like we've really gained all that much. I think we really do need to be able to understand it for it to have value. What this is good for, I think, is handling a vast amount of data that humans can't conceivably do that because of, they have to go to the bathroom and they have all kinds of other things that they need to do. And so computers are good at not needing to do any of that. And so it can help us deal with the huge mass of data that we have to deal with. But I think we should always...
In the end, like you mentioned it last week, that if you give it a certain set of data and then it spits out data at the end, then you take that data and then you check it, right, for validity or whatever, right?
Well, that's what we can do right now to test how valid these algorithms are.
Then you're also not like learning anything about the process, I guess. I may be saying that incorrectly, I don't know.
Well, we're not learning anything about the process of orbital mechanics in that process. We're learning about the process of this machine learning algorithm.
Yeah,
maybe.
Exactly.
But then say we like use this to predict every orbit known to man ever and just had humans stop doing it. Well, what if we then set it to now check for all the asteroids coming in at us. Well, what if it missed one? Yeah, like then we would be screwed, and it might have been one that a human might have seen. You know, it's a very contrived situation that I'm building up here just to kind of elicit the point that like it might be skewed towards the data. Even if we give it a lot, it still might be skewed towards that and make false predictions. And if we can't have that sanity check to be like, oh, well, this is why it went wrong this time, then it's like we don't really know what to do about that other than to maybe try training it some more and hope it gets better at its job.
Well, let me ask you this too. I mean, us as our understanding, all of our knowledge, we still only have limited data sets, yet we're going to make our predictions and we're going to observe and we're going to do what we do, our scientific method, and it's good enough for us. So why would it not be good enough for this thing to do it for us? I mean, we don't know exactly what goes into every individual person's thought process that leads them down this road. All we do is get them a set of instructions. What instructions are those? What we have observed over the years, what seems to work. So ultimately, it is exactly the same thing as a person, just not. I mean, it doesn't have the understanding and the intelligence that a person does, but it's doing the same thing that we do. It's taking one point of data, something we've observed, that we gave it, and it's making predictions based on that data.
Right, but you can in turn ask a human, like, I mean, they teach you this back in like school with the kids, you know, like the whole show your work bullshit. It's like, okay, here's the problem, here's the answer. How did you get the answer? Well, this is how I got the answer. The machine not doing that. Black box not doing that.
But don't you have to input the equation to be able to get it out, right? So if we're only giving it an algorithm, something to say, okay, take this, 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 and this, then don't we already have the instructions of how it's getting what it's getting?
No.
This is what I'm saying though. When you're doing math, when a person is doing math in your example, there is an equation that goes into it. That is the set of instructions, okay? In the case of the orbital physics, Newtonian physics is what we know, what we have devised to be the set of instructions for how orbiting bodies work. So we just didn't give it that one piece of information, but we gave it another piece of information, which is how these orbits are, and said, now see what you can understand. And it understands that other planets are going to act the same way.
But
so it's just, I'm sorry, go ahead.
But we can't double check that. That's my big issue with it, is like, even back to like the doing an algebra problem example, I wouldn't just do it the way the teacher did it. I would do what I call a sanity check. I would do it a different way to see if I then arrived at the same number.
Now, what if we approach this differently, though? Let's not try and ever take it as the end-all, be-all. Let's just use it as a point of reference, a jump-off, a basis point. And we are the ones that do the error checking. Once it says something should be some way, now we have to figure out why. Why not? I mean, that's the best kind of error checking we're going to have anyways, right? Is doing it ourselves, if we're only ever going to trust ourselves.
Yeah, absolutely. It kind of reminds me of what I was mentioning last week of how this should never be used to create, or this should never be used to solve hypothesis. It is a hypothesis creator or a hypothesis builder. It's used to give inspiration towards the hypothesis, but you should never rely fully on the model because it is just a model.
I agree, 100%, yes. It is a tool, not the answer.
Yeah.
And then we'll have AI like you do see in the movies that does think for itself and is self-aware. And then there won't be any.
Then we're all screwed. Yeah.
Yeah. There will be no difference between us and them.
I think we're all in agreement that once AI, comes to self-awareness, we're all screwed. So yeah. Scott Blake Fox.
I don't know. That's a whole rabbit hole. There's all even different types and subtypes of even that type of.
So next time on Technically Incorrect.
For real.
You gotta sell that to the Japanese people, the companies making all the sex robots and stuff that can talk to you and react and have emotions and feelings and stuff.
From what I understand, they've gotten quite realistic.
Human emotions. Yeah, we're in for an interesting future, boys.
Oh yeah, let me tell you.
Were we born in the wrong millennia? You think?
I know, like by the time stuff gets good, I'm gonna be too old to care.
Damn.
Jojo got decapitated.
Yeah, that was weird.
There he is. You should just do the whole podcast
Crazy.
like that, Nick.
Yeah,
It's like, okay, we're good. Coming to you for, on Halloween. We're going to save that one for October.
Yeah.
Anyway, this has been Technically Incorrect. Thank you for watching. Like, comment, subscribe. See you later.
peace.
Bye.
Where's the stop? Stop. There it. No! Damn it! I did it again.